Good morning, dear students. I am Miss NAVEDA SHAIKH from Brahan Mumbai Mahanagar Palika MCGM virtual class. I welcome all my dear students to another and interesting session. In today's session, we'll be learning something new and interesting from a science textbook. So let's get started. Good morning, dear students. I am Miss NAVEDA SHAIKH from MCGM virtual class. I welcome all my dear students to another and interesting session. In today's session, we're continuing with the chapter Current, Electricity and Magnetism. So let's get started. Now, what is electricity? We have learned in a previous class about what is electricity. We have learned how this electricity flows and what are the uses of it. We have seen this earlier, and let us just quickly revise about it. Electricity is a form of energy that can be easily changed to other forms, right? We have seen that there are various forms of energy, like here you can see the elevator, the trains that move, you use computers and many other electrical appliances which make use of electricity, right? So it is a form of energy that can easily change to other forms. Now, where does this electricity come from? There are mainly two sources of electricity. First is the power station that supplies a lot of electricity. It is used in many electrical appliances. Whereas the second source is the electric cells or the batteries that we make use of in our day-to-day life, which supplies a little electricity, and it is portable, means it can be carried anywhere if you want. Whereas if you talk about power station, it is a huge structure, like how you have dams, you have power stations which generate various forms of power stations are there depending upon the source of energy that they are using. Okay, some make use of solar energy, some make use of wind energy, some makes use of nuclear energy in order to produce electricity. Whereas the second one is the electrical cell, which we make use in our day-to-day life, like from the watch or from your wristwatch, from the watch on the clock, from the toys, from the batteries which are used, etc. So these are the two main sources of electricity. Now, as I told you, the power station, we have learned that earlier. Now we will be learning about electric cells. Now there are various batteries that we make use of, different size and different shapes and different powers, right? Now if you see here the watch, if you have, it also has a battery in it. Whereas if you use the toys, it also uses batteries. Now these batteries are called as the electric cells. और we have seen, no, we say कि सेल खत्म हो गया, इसके अंदर का सेल खत्म हो गया, तो ये जो सेल है, ये इलेक्ट्रिक सेल है which supplies a source of energy to that particular object or the instrument that we are using. Such a general device is an electric cell. Various types of electric cells are available today. They are used in range of machines from wristwatches to submarines. Out of these, you must have been aware of the solar cells also, that we have learned in our previous lessons, in our previous standards. The main function of various electric cell is to maintain a constant potential difference between its two terminals. Now we have all, if I just take an example of the normal battery that you use in your toys. Now you have a plus sign and a minus sign, right? So these signs are the two sides of the electric cell. We'll be learning about that in detail, how it produces energy and how this electricity is used in order to move the object or do various functions. So the electric cells work on the electric charge to maintain a constant potential difference, about which we will be learning, and let's learn about the electric cell that are currently in use. The first one that we'll be talking about is the dry cell. The normal cell batteries that we make use of in our toys, in our watches, they come in different sizes and shapes. Have a look at it. This is just an example to show you how different types of dry cells are available in market, and you must have seen it also. So the dry cells are used in our radio sets, wall clocks, torches. These are available in 3 to 4 sizes. Okay, so here there are comparative sizes of dry cells in front of you. Now, as I told you, that dry cell is quite portable. We can use it anywhere. We can carry it anywhere. Why? Because it is a dry cell. उसके अंदर का जो भी केमिकल है वो बाहर स्पिल नहीं होता है, and there is a paste which is inside it, filled inside it, and which helps in producing energy or electricity. Okay, so let's have a look inside this dry cell. What exactly is present inside the dry cell? You have to just look at the image here carefully. Now if you cut open the outer layer, the outer sheet of this dry cell, you will find a whitish metal layer, which is the zinc metal layer. That forms the negative terminal of the cell. जो नीचे का जो layer आप लोग हमेशा देखते हैं ना, जहाँ पर minus sign लिखा होता है, that is made up of zinc, which is the negative terminal. Now, if you carefully open up this layer, you will find another layer inside, which is present between these two layers. This is the main layer which contains electrolytes, negatively and positively charged ions are there inside it, which helps in the carrying of electricity. Now, the electrolyte is a wet pulp-like substance which is made up of zinc chloride and ammonium chloride. Now, there is another thing which is present, the big rod-like thing you can see in the center, that is the graphite rod, which is in the center of the cell. Now, outside the center of the cell, there is a center of the graphite rod. There is another paste, that is manganese dioxide. Now, one more important thing about the graphite rod is it is the positive terminal of the cell. ठीक है, जिंक मेटल जो था वो नेगेटिव टर्मिनल है और जो ग्राफाइट रॉड है वो हमारा पॉजिटिव टर्मिनल बनता है. Now, outside the graphite rod, you will find another paste-like substance, that is manganese dioxide. Because of the chemical reaction between all these chemicals, electrical charge is produced on the two terminals, that is on the graphite rod, that is a positive terminal, and the zinc layer, that is a negative terminal, and an electric current flows in the circuit. Due to the wet pulp used in the cell, the chemical reaction proceeds very slowly, hence a large electric current cannot be obtained from this. ठीक है, हमारे यहाँ पर जैसे कि जो भी इलेक्ट्रिसिटी यूज होती है, like in your wrist watches or the watches on the wall or your toys, they do not make use of large amount of electricity. तो उसके लिए ये dry cell sufficient होती है. ठीक है, उतना amount of energy जो release होती है वो slowly release होती है. So that much is enough for the toy or the objects that are there in our houses which work on these dry cells. Compared to the electric cells using liquids, the shelf life of dry cell is much longer. You must have seen, अगर हम लोग watch में या हमारे remotes में remote controls में अगर हम लोग ये dry cells डाल देते हैं तो they work for about 6 months also, sometimes a year also in the clock, right? So they last for a longer period of time. The dry cells are very convenient to use as these can be held in any direction with respect to ground and can be used in mobile instruments as well. Mobile instruments means movable. We are using it here and there, wherever you want. You can take it, you can travel it. इसको ऊपर नीचे करो, उसको कोई फर्क नहीं पड़ता. Okay, you are not going to spill out anything from the back cell. So I hope dry cell is clear to you all. You have to remember the name of the chemicals that are there in this cell, and that way if you remember the diagram, it will be easier for you all to remember the entire dry cell. Let's move on to the next type of cell, that is the lead acid cell. Now why are we learning this cell? Because this type of cell can be recharged after getting electrically discharged. मतलब उसका जो केमिकल है अगर वो खत्म हो जाता है उसके अंदर तो हम लोग उसे फिर से रिचार्ज कर सकते हैं. The lead acid cell contains a lead electrode. Here you can see lead electrode and a lead oxide electrode. दो electrode है, एक PbO2 that is lead oxide and other is the lead electrode, सिर्फ lead electrode है. ठीक है, and both are dipped in a dilute sulfuric acid solution. Now, lead oxide carries a positive charge while the lead electrode carries a negative charge. You have to remember this. The potential difference between these two is nearly 2 volts. Because of the chemical reaction between the substances in the cell, electrical charge is produced. Same thing जैसे हम लोग ने dry cell में पढ़े, जो भी chemicals involved होते हैं वो react कर रहे हैं ना, like lead है, lead oxide है, sulfuric acid है, they keep on reacting with each other, which because of this reaction electricity is generated. Okay, and the electric current flows through the load in the circuit and which helps in glowing the bulb, whatever it is connected to. This kind of electric cells have a capacity to deliver large current. Okay, not very large current, हमारे घरों में इस्तेमाल नहीं कर सकते, but large current where you can see the uses are done in car, trucks, motorcycles, and uninterrupted power supplies. So here you can see these batteries which I've taken for example. You must have seen it in the cars also. You must have seen it in your bikes also. बोलते हैं ना कि बैटरी खराब हो गई है, बैटरी ड्रेन हो गई है, तो वो बैटरीज यही लेड एसिड सेल की बैटरीज होती है जो यूज होती है. ठीक है. So I hope this much is clear to you all. Let's move to the next cell, that is nickel and cadmium cell. Now this nickel and cadmium cell is very useful because it is a rechargeable battery again. You must have seen various batteries which we make use of with the help of a charger. ठीक है, ये बैटरीज को हम लोग चार्ज कर सकते हैं अगेन एंड अगेन. जो हम लोग नॉर्मल ड्यूरा सेल का या एवरी डे का हम लोग जो सेल्स लाते हैं, those cells if you use it for a few months or year for a few months or days, it has to be thrown away. You cannot recharge it. But these are special cells which are made up of nickel and cadmium. Okay, these are the chemicals which are used in this, and a very simple example is your mobile phones. हमारे जो मोबाइल फोन्स के अंदर बैटरीज होती है वो निकल कैडमियम की होती है बिकॉज दे कैन बी रिचार्ज अगेन एंड अगेन. ये बैटरीज को हम लोग वापस रिचार्ज करेंगे, फिर से इसका फिर से इलेक्ट्रिसिटी प्रोड्यूस कर सकते हैं. ठीक है. So this is also a very important thing that you need to remember because it is related to your day-to-day life. All right. Let's move on and understand how does an electrical appliance work. अभी हम लोग ने देखे कि ये जो छोटे छोटे इंस्ट्रूमेंट्स, छोटी छोटी बैटरीज है, ये किस तरीके से इस्तेमाल हो रही है. Whereas if we talk about our electrical appliances in our house, how do they work? To make an electrical appliance work, we need electricity, and electricity must flow through it. The flow of electricity is called electric current, and the path along which the electric current moves is called as the electric circuit. Now remember this, when I'm talking about electrical appliances, any electrical appliances, whether it uses the normal electricity that you get from the power supply, or if you are using of say for example the dry batteries or any battery that you're making use of, this will involve electric current flowing through it and it will involve a electric circuit also. ठीक है, तो ये दो चीज important है. So we will be talking about this in a further class. See, what is an electric current? Now electric current, remember this diagram. You have a bulb, you have a battery. ठीक है, अभी हम लोग ने बैटरीज के बारे में पढ़े हैं. पॉजिटिव टर्मिनल, नेगेटिव टर्मिनल, इसके अंदर रिएक्शन होता है तो करंट जनरेट होता है. ये जो करंट जनरेट हो रहा है, ठीक है, जो करंट हम लोग ने पढ़े उसके बारे में. Now that is because of the electric current which is flowing through the battery and the circuit that is there. ठीक है. The flow of electric charge, ये जो electric charge flow होता है उसकी वजह से electricity या electric current generate हो रहा है. Now electric charges made up of positive charges, that is protons, and negative charges, that are electrons. When these charges flow in a circuit, a current is produced. So anytime if you see this diagram, electric charge flow होने के लिए दो चीजों की very important things are, you have to remember about positive charge protons and negative charge electrons. When these charges flow in a circuit, a current is produced. Now how does electrons flow? The battery in a circuit gives energy to the electrons and pushes them around in a circuit. So here you can see जो बैटरी है, जो ब्लू कलर की बैटरी दिखाई दे रही है, वो इलेक्ट्रॉन्स को पुश करती है ताकि वो मूव हो, और जब वो सर्किट में मूव होती है तो वो इलेक्ट्रिसिटी हेल्प करती है, like to if there is a bulb attached to it, it glows. ठीक है. So battery in a circuit gives energy to the electrons and pushes them around a circuit from the negative terminal of the cell around the circuit and back to the positive terminal of the cell. So this way electrons are flowing because of the battery and which helps in generation of electric current. ठीक है, simple है ना एकदम. Ahead, let us understand about what is electric circuit. अभी हम लोग पढ़ रहे थे इलेक्ट्रिक करंट फ्लो होता है बैटरीज की वजह से. किसमें फ्लो हो रहा है? जो वायर्स है, जो बल्ब है, जो बैटरीज है, ये सारी चीजों के थ्रू इलेक्ट्रिक करंट फ्लो हो रहा है. ठीक है, ये सारी चीजों को जब हम लोग जमा करते हैं ताकि इलेक्ट्रिक करंट फ्लो हो, That is called as electric circuit. Alright, so electric circuit, if you see here, electric circuits are made up of electrical components. These components must be joined together always without any gap in between to form a closed circuit. Now I'll give you a very simple example. Now whenever electrical connections are done in your houses, you have a switch which is there to put it on and put it off, right? If you put on the switch, the appliance starts to work, and when you put it off, it doesn't work. Now that is because of the electric circuit which is being done in your house. Okay, so let's have a look. So when we talk about incomplete circuit, here you can see that there is a bulb, there is a wire, one side is connected to the battery and the other side is not connected to the battery. Now, another side, there is a connecting wire which is missing. So do you think the current will flow? No. Because as I told you in the very beginning, that in order to the current should flow, there should be all the components and there should be no open ends. Okay, so everything should be connected to each other in order for the electric current to flow through it and to generate electric current, right? So electric circuits, if you see here in these two examples, in one place there is no connecting wire and the other place there is no source of electric energy. That means the battery is missing. तो अगर बैटरी नहीं रहेगी और वायर्स कनेक्टेड रहेंगे तो किस तरीके से एनर्जी क्रिएट होगी, बल्ब चलेगा नहीं. So both the circuits in the diagram are incomplete. Hence they are known as open circuits. An electric current flows only when there is a source of electrical energy and a closed circuit. Okay, so here in this picture you can see that there is connecting wires, you can see electrical cell, you can see a light bulb and you can see an electric circuit board. Now things have to be connected to each other. A very important thing is the switch. A switch is used to open or close a circuit, as you have in your houses also. The main switches which is used in the buildings or in your apartments, where you make use of the switches to put the appliances on and off, which is just based on the circuit. ठीक है, अगर हम लोग इसे ऑन करते हैं तो सर्किट कंप्लीट हो जाता है और अगर हम लोग उसे ऑफ कर देंगे तो सर्किट ओपन हो जाएगा और करंट फ्लो नहीं होगा. So these are examples of switches which are used on circuit boards. Let's have a look at open circuit bulbs. Here you can see there are two examples of circuit diagram for open and closed circuit given to you. This is an open circuit where the bulb does not light up. Why? Because the switch is open. ठीक है, एक end open दिखाई दे रहा है आप लोगों को. That is the switch which is open and the current will not flow, and it is called as an open circuit. Whereas on the other side you will see that the switch is closed and the circuit is complete and therefore the bulb will light up. Now in order to draw circuit diagrams, we normally do not make use of, every time we do not draw a proper cell or a switch or a wire, we just make use of symbols. So these are a few symbols of electric cell or of a light bulb, connecting wires, or you can see how the switches resembles, how you put on a switch button. ठीक है, एक symbol, how do you put it on and how do you close the switch, both are given to you. If multiple batteries are used, the symbol is given to you.
Most of us have seen it. You know, this bell also works on electromagnet. Confused? Let us first refresh our memories. We already know when the electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of electric current. Also, a current carrying coil of an insulated wire wrapped around a piece of iron is called an electromagnet. The power of this electromagnet can be increased by increasing the number of turns of the coil. It can also be increased by increasing the flow of current through the coil. Let us also not forget, electromagnet can also be turned off by stopping the electric flow of current which made it a magnet. Now that we are clear about the electromagnet, let us now understand how an electromagnet is used in the functioning of an electric bell. Let us see the simplified circuit of an electric bell with the switch in off position. It consists of a coil of wire wound on an iron piece bent to form U shape like a horseshoe magnet. A spring-loaded arm made of an iron strip is kept close to the electromagnet. This arm has a hammer attached to it at one end. Let us call it a clapper. A small gong or bell is also placed near the hammer. See, there is a contact screw near the clapper. Now, let us switch on the circuit and the fun begins. Right now, the clapper is in the contact with the screw, so the circuit is complete and the current flows through the coil. Due to the current flow, the coil becomes an electromagnet. The electromagnet then pulls the clapper towards itself. In this process, the hammer at the end of the clapper strikes the gong of the bell to produce a sound. Let us see what else happened when the electromagnet pulled the clapper and we heard the hammer striking the gong. Look closely. Right now, the clapper is not in contact with the screw. The circuit is broken now. So what will happen next? The current through the coil will stop flowing. Will the coil remain an electromagnet? No, it wouldn't. The coil is no longer an electromagnet. As we know, it's the flow of the current that gives the coil its magnetic power. So, it no longer attracts the clapper. The clapper springs away from the bell back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated again and again very quickly. Thus, the hammer strikes the gong every time the circuit is completed. This is how the bell rings. Interesting application of an electromagnet, isn't it? So, in a nutshell, by turning an electromagnet on and off, we made a useful thing, an electric bell. Using this electromagnet, we created the movement of the clapper to ring the bell. With the current flow, the electromagnet attracted the clapper, ringing the bell. But it also broke the circuit and stopped the current flow. Due to this, the electromagnet lost its magnetic power and the clapper went back to its original position, making the contact with the screw again. This made the circuit complete and again the clapper struck the gong. Great, isn't it? So the next time if you get any chance, do analyze the circuit.
So I hope with this the chapter is quite clear to you all. In the next coming period, we learn something new and interesting. Till then, thank you.
If you liked our video, please subscribe to our channel and do not forget to hit the like button.
Hope this session was quite useful to you. In the next coming period, we'll learn something new and interesting. Till then, thank you.